This video is about reaction kinetics. Here I'll discuss about the basic of this chapter. This is the video 1 of this chapter. Rate equations. Let us consider an equation A reactant to the product. Here rate of reaction proportional to the C to the power n. C is the concentration of the reactant A. So rate of reaction is equal to Kc to the power n. Here K is the rate constant and n is the order of reaction. The formal definition of order of reaction, the power to which the concentration of a particular reactant in the rate equation is raised to is known as the order of reaction with respect to that reactant. So R is equal to, that is rate of reaction is equal to Kc to the power n. So if n is equal to 0, this is zeroth order and the equation is rate of reaction is equal to K. If n is equal to 1, this is first order and rate of reaction is equal to Kc. If n is equal to 2, this is second order, so rate of reaction is equal to Kc square. Rate versus concentration of zeroth order reaction. Here already I have told the rate of reaction is equal to K. So in the graphical relation, y-axis rate and the x-axis concentration. So this is the relation, rate is equal to constant. With concentration changes, rate does not change. Now, rate versus concentration of first order reaction. Already I have told rate of reaction is equal to Kc for the first order reaction because n is equal to 1 in the rate equation. So, the graphical relation, rate versus concentration, this is the relation, this is linear relationship and the gradient is K. Rate versus concentration for second order reaction. Here we know n is equal to 2, so rate of reaction is equal to Kc square. So in the graphical relation, rate versus concentration, so here the gradient is the K. Here the relation is exponential relation. To discuss concentration versus time for the zeroth order reaction. We know here the reactant A to the product and here the relationship is rate of reaction proportional to the C to the power n. Here C is the concentration of the reactant previously I have told. So here the definition of rate of reaction, change of the reactant and to the change of the time. So here negative change means concentration decreases with time being. So here if we put 0 minus dc by dt is equal to Kc to the power 0, that is K. From simplifying here, minus dc is equal to K dt. So taking integration sign, and now after completing the integration, minus ln c is equal to Kt plus constant. So c is equal to minus Kt plus constant. Putting this value in the graphical relation, y-axis concentration and x-axis time. And this is the relation and the gradient is negative K. And I want to discuss now rate versus concentration for the first order reaction. This relation already I have discussed. I want to start to discuss here n is equal to 1 minus dc by dt is the definition of the rate of reaction is equal to Kc minus dc by dt is equal to K dt. So after performing the integration, minus ln c plus Kt is equal to constant. We are considering this is an equation 1 to discuss it easier way. So here if t is equal to 0, c is equal to c naught, that is initial concentration. Putting this value in this equation, we get minus ln c plus k into 0 is equal to constant. So constant is equal to minus ln c. So the equation is minus ln c Kt plus minus ln this value here. We are getting the equation ln c minus ln c naught minus ln c is equal to Kt. So ln c naught by c is equal to Kt. From here c naught by c is equal to e to the power Kt. C by c naught is equal to e to the power minus Kt. So c is equal to c naught e to the power Kt. This is the first order reaction. So concentration versus time for the first order reaction, we are getting y-axis concentration, x-axis time. This is the relation. Concentration versus time for the second order reaction. We want to discuss here n is equal to 2 minus dc by dt is equal to Kc square minus dc by dt is equal to rate. It indicates concentration decreases time being. So here we are rearranging and taking the integration. minus 1 by ln c is equal to kt plus constant. So 1 by c is equal to kt plus constant. 3 is equal to 1 divided by kt plus constant. Putting this relationship, we can make the graphical relation for the second order reaction, the blue line. We are here also comparing with the first order reaction. Concentration versus time for the zeroth first and second order reaction in the same graph. Concentration in the y-axis and the x-axis time. This is zeroth order, first order and the second order. It will be easier for the candidate to compare. Half-life of first order reaction C is equal to C naught e to the power kt, which we have derived few slides before. So here the first order reaction when T is equal to T half. So here T is equal to T half, at that case the initial concentration will be the half of that. So C is equal to C naught by 2. So putting this value in this equation, we get C naught by 2 is equal to C naught e to the power T half. So here cancelling out C naught, half is equal to e to the power kt1. So we are taking ln both sides, e is cancelled out. This is the simple relation. T half is equal to constant ln c by 2. T half is equal to ln 2 by k. This is constant. Putting this value of ln 2, 0.693 by k. This is the half-life of any reaction like that. That is first order reaction. This is the relationship, graphical relationship, x-axis time and y-axis concentration. From here the first half-life is this one, and the second half-life, these two half-lives are constant. So this is the first order reaction. So for first order reaction, half-life is the constant. Please see the next video to understand clearly rate of reaction.